All right, let's see if I can finally get this working. So, look, I'm just going to kind of go through a couple of the problems that are in that first set of notes. And then we'll and if you guys have any questions as I go through and do this, please send me an email, and we can kind of meet up on a Google Hangout and we can be all set with that. But kind of the first one that I kind of want to look at is that first problem, that y is equal to x squared plus 2x plus 7. And if you look at that, I give you, and if I just ask you to derive this, most of you would be pretty good with that. You get 2x plus 2. And just going from here to here, I feel like you guys would be pretty good with that. So what we're actually going to be doing this with integrals is anti-differentiation, which works backwards. So if we were given this y prime is equal to 2x plus 2, how can we possibly get this equation, this x squared plus 2x plus 7 value into that? So what we do is we actually just look at it piece by piece, just like what we did when we were deriving. So if I look at this 2x, what we look at is we actually look at what we would do when we use the step down rule. So we made this 2 into a 1. So now what we're going to do is we're actually going to step up. So now this is called the step up rule. So when we're looking at trying to find out what y is equal to, if we weren't given what it was actually equal to in the top, we can get that it's equal to x squared, because we know if we derive x squared, we get 2x. And then if we look at what we can do with this 2, well, this 2 just comes from 2x, because if you derive 2x, you just get 2. So we know that that's what it's going to be equal to. The problem lies with what happens, how do we get this 7 value? Well, we got this 7 value because we know that if we derive any constant, when you derive a constant, you end up just with 0. So what we say is we say that this is just plus c, and this c is just a constant. Okay, so since this c is just a constant, we don't really know what it is, but what we need, if you look at the notes actually give us a specific point. The notes give us the point 0, 7. So if you plug in 0 for your x's and 7 for your y values, you can easily see that these two would cancel. This y would be a 7, and so that in this case, c would equal 7, which also makes sense because this is the y-intercept. So we would get y is equal to x squared plus 2x plus 7. Now, if you weren't given a point, you would just leave this as your answer, knowing that it would just be more of a general solution of what our answers would be, because we don't have what our c value is. Okay, looking at the next one is if we were given y prime in this case, so y prime is equal to 7x to the third plus 3x squared minus 4x plus 2. If we look at this equation and I want to find out, well, what is y equal to? And so if I'm given what y prime is, how can I possibly find out what y is equal to? Well, thinking of the step up function or step up formula, so we go from x to the third to x to the fourth, because I know if I derive x to the fourth, I'm going to step down and get to x to the third. The question now here is, how did I get, or how, this is a little bit different because I have this 7 here now. Okay, so how did I end up with just 7? Okay, well, what would I have to derive? Well, if I have a 7 here, and I know I'm doing the step down when I'm deriving, I know I'm going to multiply this first number, I know I'm going to multiply it by 4. So how would you get rid of multiplying by 4? Is you would divide by 4. Okay, so kind of think of that the other way. So rather than multiplying by 4 when we're deriving, what we want to do is we want to just take this 7x to the fourth and divide that by 4. So what's kind of nice is that this number and this number should always be the same. So if we look at the next one, this 3x squared, this becomes 3x to the third over 3. This 4x becomes 4x squared over 2. And then this, then this 2 just becomes plus 2x plus some constant at the end. Okay, so if you look at that function, what it's actually equal to is this function is actually equal to y is equal to 7/4 x to the fourth plus x to the third minus 2x squared plus 2x plus c. And we just leave it with that plus c because we weren't given an initial point to help us find out what that c value is. Okay, so as you go through and look at these, so those are two kind of good example problems as to how you can look at thinking of the step up function. I know that there's a good video as well with that as well included in those resources. I'm going to go through just the next one now, and this will be the last one that I kind of look at. So if y is equal to the sine of x plus the cosine of x. And so we have y prime, so we want to figure out what y is equal to. So now we just have to think of, well, with the trig functions, you really want to think of what the derivatives are and then kind of think of it backwards. So we know that the derivative of the sine is the cosine. We know the derivative of the cosine is the is the negative sign. So if you think of it backwards, if I derive the cosine, I know I'm getting something in terms of the sine, but that would be the negative sign. So what we have to do is we have to negate the cosine of x to help us get us to this sine of x. And then you're just going to add the sine of x because I know the derivative of the sine of x is the cosine of x. So kind of thinking of it backwards is a good way to kind of go through and help you with that. I did mention a couple things. If I know that y prime is equal to e to the x, well then y is just also equal to e to the x, but don't forget that plus c. I did forget it up here as well too. So don't forget the plus c because there is always a constant, whether it's 0 or not. And also if y prime is equal to 1 over x, that's equal to the natural log of x plus c. Okay, and in this case, what you also have to always think of is that this x has to be the absolute value because you can't change the domain if we're given this function. So x can be negative values there. So that's why we have to use the absolute values here because x can be a negative value. So we have to plug that in and don't forget the constant. If you do have any questions on this, please let me know. I can kind of go through and help you out with these. I know there's a couple more problems. Hopefully, as you just kind of go through and look at them, there is an example. The next one would be a reverse chain rule. You guys don't have to worry about that as much right now. But they're just kind of looking at antiderivatives and what they're being called, how we can use that step-up function, step-down function. There are a bunch more examples in that. I don't want to go through every single one, but if you are having some trouble with it, please let me know. I can go through some of them with you, especially the worksheet ones we're going to go through on Thursday. So other than that, you guys have a good day and